Okay, so we are now recording. Okay, so this is from last week's Desmos activity, and what they want is they want to know what does a of x equal to, right? That's the question. And they gave us a little bit. They said, okay, you've got this rectangular field that you're building, right? And what you know about it is that 50 feet or 50 meters of fencing is what you got, where we call, say, this x, and we call this y. And so what that means is, knowing what I know about the formula for the perimeter of a rectangle, perimeter is equal to twice the length plus twice the width, right? Then that means the 50 has got to be equal to 2x plus 2y. So Sarah, what do you think? Is that okay so far?
Yeah.
So that's just basic geometry stuff, not anything fancy schmancy here, okay? So get my color palette where I can get to it here. So what that tells me then is that what I'm going to need to do, what is with you? Stop that. Hang on just a second here. Okay, well, you're going to go right there then, I guess. So what that tells me is this, is that I need to come in and do something about fixing this area function, because the area of this particular rectangle right here is going to be given by x times y. That's how you find the area of a rectangle. You take its length times its width, okay? But what I'm going to need to do is I need to get it all as a single function of x, not of x and y. So the trick that we do is this, is we come over here and we say, okay, take 50, subtract 2x from it, and that'll be equal to 2y. And then divide both sides of this by 2. And then we get 50 over 2 minus 2x over 2 is equal to y. Or 25 minus x is equal to y. Okay, so stop for a minute. Did that make any sense at all, Sarah?
Yeah, I think I figured out that part in the
Okay.
discussion. It was
Cool.
after that I got completely lost.
Okay, well, let's see if we're going to take this thing home then. So we know that everything in the red box is the same. So if everything in the red box is the same, then that means that my area function with respect to x is equal to x times 25 minus x. In other words, I dumped out the red box where the y was, and I put in its place the 25 minus x. Okay, so going back to the discussion question here, that's the first question, okay? So question 1 was, if you know the length of the field x and the perimeter is 50 meters, then what equation gives us the area of the rectangle? Excuse me. So that function that we've got right there, that is part A right there. That's the area of the rectangle.
Okay. So I think I got that far in the discussion. I have that part in front of me, but
That's
I
cool.
Did y instead of
Okay, but if you got that good, does it make sense though where that all came from? Okay, cool. All right, so let's go back and see what the second question is. Okay, you still have 50 meters of fence, but you're building along the x-axis like it's a wall. You only need fencing on 3 sides of your field. Write down the dimensions and how you figured it out.
Okay. So would that just be 1x plus 2y or whatever it was?
Yeah, so in other words, it's you can think about it this, is that one side of it is a wall.
Yeah. So it would just be the perimeter would just be x plus 2y.
Exactly. So now
okay.
The perimeter is equal to x plus twice y. So far, so good?
Yes.
Okay, and I don't think they wanted anything more from us than that, right? Okay, so what we got to do is we got to go figure out real quick using the 50 here. So that's 50 is equal to x plus 2y.
And you would just subtract the x from both sides and divide by 2 again?
You got it, exactly. So 50 minus x over 2 is equal to y. And so now that what that tells me is that my dimensions are x by 50 minus x over 2. Because that's what the y is equal to. So in other words, my length would be equal to x, and my width would be equal to 50 minus x over 2. If you wanted to, you could simplify that and write it as 25 minus x over 2, and that's fine also. Either of those is good.
Okay. Well, that makes a lot more sense now.
Okay, so let's take a look at the last one. What do they want the last thing here? They say, let's say you don't have 50 meters of fencing, but you have 60 meters or 600 meters or m meters of fence. Write down instructions on how you would find the dimensions of the biggest field given any length of fencing, and give the function a of x for 60, 600, and m respectively. So now we're going back to part 1 again, okay? Because we're talking about a of x that they had in part 1. So let's get a fresh sheet here, okay? I'm going to go ahead and erase all of this. So what they want now is they want to know what is a of x equal to if your perimeter, if p was equal to 60, 600, or m, if I recall correctly. That was just the 3 ones they wanted us to look at? Yeah. Okay. So the thing to remember is that you had whatever your perimeter was here, p, it was equal to twice x plus twice y, wasn't it, right? So in order to find out what your function is as a function of x, you're always going to take the perimeter, subtract from it 2x, and then divide both sides by 2, right?
That makes a lot of sense to me now. I think I get it.
Okay. So if I wanted a of x with, let's say, with 60, right? If we had 60 meters of fence, then a of x is going to be x times, well, then it's going to be what? 60 minus 2x over 2. And I'm going to leave it unreduced just to help it make sense, see what's happening as we go along, right? And now what if we had 600 meters of fence? Well, then a of x would be equal to x times 600 minus 2x over 2. You getting it?
Yes.
Because my perimeter just goes in right there, whatever I have for p, right? Okay, so if I have m meters of fencing, then a of x is going to be equal to x times m minus 2x over 2, right?
That makes a lot of sense to me now.
Okay.
I guess I just needed to. Yeah.
Okay, so do not be shy about going in and updating it, okay? I have not graded it yet. I'm not going to probably grade it till tomorrow.
Okay.
So if you want to go in and update it, you're just going to lose a point or 2 for turning it in late, but you're not going to get a major amount deducted, okay?
All right, perfect.
Okay, so you said something else about 8.3, and then anybody else have something that I can put on the back burner in the cooker waiting to go? Janelle or Jennifer, do you have something you want to?
I did not do, I don't know if I did 8 and 9 right in the practice problems.
From the chapter 8 stuff?
Yeah, 8.3.
Okay. Well,
We'll
cool. We're going to 8.3 right now, so we'll put it on there. Janelle, have you got anything you're looking for?
I believe on lesson 7, on assignment number 17 is where I kind of got stuck.
Okay, so number 17 from assignment 7?
Yeah, it's 7.5.
7.5. Okay, cool. We will go back there. Let me go do 8.3, and then we'll come back and we will get these, all right? So let me open a fresh window so I've got these saved where I can keep them, okay? So I got myself a little cheat sheet there. All right, so let's see, 8.3. I'm up way too far. I'm in 8. There we go, 8.3. So how to solve quadratics, right? Is that the one we're looking at?
Oops. The application of quadratic functions.
Yeah.
Ava, can you go plug Daddy for a little bit?
No, Daddy's
Word problems, is that what you're saying? The dreaded beast? Okay, applications of quadratics. Okay, so Which was 8 and 9 from there? Was that the two that we were doing?
Those are the ones that I had issues with, I think. I don't know what Sarah was questioning.
Sarah went away for a moment, so hopefully she'll come back. Maybe she lost. Yeah, you know, I don't. My internet's kind of wonky tonight. I was warning Sarah when we started that it might.
No.
It might crash. So hopefully it doesn't. Hopefully it doesn't. If I get pixelated and all of a sudden stop talking, it's not. Just be patient. I'll be right back. Okay. Just like Sarah. Sarah came right back. Are you there? Can you hear us?
Yeah. I guess my internet's not being that great tonight either.
No. Okay. I'm pretty sure it's this wind. It's because it was. Yeah. All right. So 8 and 9, is that the ones we're looking at, Sarah?
Yeah.
Okay. All right. So companies' revenue earned from selling X items is given by R of X equals 680X, and the cost is given by 1,000 plus 2X squared, right? So write P of X as a function of the profit.
So is that like from Nike that it goes on? Ow! Stop! Where he's up and he already said it and did what he's doing. It's just like
So you guys, there's a control you can use on your microphone. You can go ahead and you can mute yourself. You see? So if you do that, perfect. Thank you, Jennifer. So it makes it easier for all of us to hear. So, okay. So let's go ahead and take a look at this one. So write a function P of X. So what we have to remember, something all good capitalists are supposed to know, is that profit is equal to revenue minus cost. So if I want to make the profit function, I have to take the revenue function and subtract the cost function from it. So in our case, the revenue function is equal to 680X. So R of X is equal to 680X, or $680 for every one of them that we sell. And our cost function is equal to 10,000 plus 2X squared. Is that right? So 10,000, got that number zeros? Yeah, I did. Okay, cool. All right, so what that means is in order for me to calculate what my profit function P of X is, I have to go take R of X and subtract from that C of X. So that's going to be equal to 680X minus 10,000 plus 2X squared. Okay, so let me stop for a second. Is that making sense? That's okay?
Yeah.
This is Econ 101. It's like the beginnings of Econ. All right, so now what? Well, got to remember that that's what? That's a -1 sitting out there, right? So we're going to distribute that. So if we distribute that, we get 680X minus 10,000 minus 2X squared, right? So far, so good?
Yeah.
Okay, so if we put that in descending order, make it look like it's in standard form, that's minus 2X squared plus 680X minus 10,000. All right, so that one, that's part A that we just finished right there. We just finished that P of X is equal to minus 2X squared plus 680X minus 10,000. Okay, so identify the vertical intercept of P of X, write it as an ordered pair, and interpret the meaning in a complete sentence, okay? All right, so we don't need to do this graphically, we just need to do it algebraically. They want to know what the vertical intercept is. So the vertical intercept, that's the y-intercept, right? So the vertical intercept is the y-intercept. And when I like writing down the y-intercept because what that tells me, as soon as I see y has been taken, that must have meant that x was equal to 0. And if we think about that from a graphical standpoint, that makes perfect sense because when I'm on the y-axis, then there's no x movement. In this case, I'm way down to here, as we'll see in a minute, and that kind of makes sense because remember well, let me just bring it back over here. Our profit function again was negative 2x squared plus 680x minus 10,000. So if we put in a 0, in other words, we let x be equal to 0, in other words, we calculate what p of 0 is, notice that this term right here, the leading term, and the linear term, both the quadratic and the linear term, those are going to both drop out to 0, aren't they? Because, you know, negative 2 times 0 squared is 0, and 680 times 0 is 0. So that whole thing is going to reduce to negative 10,000. So they wanted us to give that to them as an ordered pair, so that would be 0 by negative 10,000, and they wanted us to interpret what the heck does that mean? Well, let's go back and look at this thing for a minute. See the cost function right here? See that number right there on the cost function? That's what's sometimes referred to as fixed cost. It means I had to cough up $10,000 to start my company. So before I even made a single item, I had to have $10,000 worth of capital to get going here. You can think about like maybe being a food cart or something. So to get the food cart going, I needed $10,000 up front. And then for every, you know, falafel I sell out of my food cart, right? It costs 2 times the cost of the falafel squared is going to increase my cost, which again, that makes sense. If I'm making falafels, let's say, every falafel I make, I got to pay something for it, right? Well, over here, these are super expensive. These are gold-plated falafels. I sell them for $680 each. Right? Because that's my revenue function. And that says I make $680 for every one of them that I sell. So if I don't sell any of them, then this part right here goes to 0, and I'm out to $10,000 that I invested in this company without ever making any money. So the vertical intercept is going to be 0 by negative 10,000. And the meaning is a complete sentence would say that I lose $10,000. I'll let you make a complete sentence out of that because you can see my little pen guy freaks out when I go over and start writing on here, okay? So that's not a complete sentence. You get to do that part for me. All right, so how much must be sold in order to maximize the profit? Okay, so can I get rid of all my work from this one? This was number 2, right? Give me a thumbs up if you're good. We're good, I can clear this all off? Yep, all right. Bombing it, here it goes, gone. All right, so they want to know where's the maximum profit at, right? We're all good capitalists. We want to know what our maximum profit's going to be, right? Well, let's think about this thing for a minute. This is a quadratic function, and notice that a right here was less than 0, so we know it's concave down or it opens downward, doesn't it? So our function looks not quite unlike but similar to this, where this is my x, and this is my p, which is my profit, okay? I know that the intercept's down here at negative 10,000. In other words, I lost $10,000 if I don't sell a single one of them. But then my profit starts to increase as I'm selling them, and then it's going to turn around, and it's going to come back down again. Because if I make too many of them and get market saturation, they're not worth as much. People don't want them anymore. Over it, moving on. Everybody's got an Apple Watch. I don't need one anymore. Let's be done with this, right? But if you think about it, where's the maximum profit going to be? Well, it's at this peak right here, isn't it, right? So if I can figure out that point right there and how many I made right here, then I'm going to know what my maximum profit's going to be, and I'm going to know how many of them I got to make to do that, right? Okay, so what is the name of that red point right there? It's got a name. What do we call it? Don't all answer at once now.
Not the horizontal intercept, right?
Nope.
No, that would be
Nope. The horizontal intercepts are right here and right here, aren't they, right?
That's right.
Is it the vertex?
Ah, yes it is. It's the vertex, isn't it, right? So that bad boy right there, that's the vertex. Oh, but wait, there's more. We have formulas for the vertex, don't we? Yeah? So the vertex, the ordered pair for the vertex is at minus b over 2a by f of minus b over 2a. So if you're thinking about getting some new ink this weekend, that might be a good thing to go for, okay? Get on the forearm there, cheat sheet, whenever you need it. So what I need is I need my function, my profit function here. I need to go figure out this point right here, the x value of my vertex, which usually goes by the letter h. In other words, this ordered pair is typically represented by the ordered pair h and k. Okay, so h is going to be equal to minus b. Well, let's see, that's minus 680, right? I got a 2 there, silly me. Okay, so that's minus 680 over 2a. Well, the a was a negative 2, wasn't it, right? See, there's my a and there's my b. So that's over negative, actually it's a positive 2 times a negative 2, isn't it? Okay, so that's at negative 680 divided by negative 4. Could you do that for me? Somebody got a calculator handy? Get mine going here on my phone. Let's see.
It's 170.
It's 170? Great, thank you. Okay, so what that gives me this point right here. So that tells me that I want to sell, the maximum profit's going to occur when x is equal to 170. So sell 170 of these, my shareholders will be happy. I'll have made as much money as I can off of this, right? Okay, what about k? To figure out k, this is really where you're going to need your calculator, because to figure out k, part of the vertex, you take negative 2 times 170 squared plus 680 times 170 minus 10,000. Okay, can you do that part for me? I'll do it too, so let's see what we got here.
I got 47,800.
47,800?
Yeah.
So what that is, that number, that's the profit right there. So that's the profit, and that's the number made. Okay, so let's go back and see if we answered their question or not. So how many items must be sold to maximize the profit? Okay, so we gave them more than they needed. We need to sell 170 of them. What is the maximum profit? Oh, cool. We already answered that too. It's 47,800, right? How many items does a company need to sell in order to break even? All right, so what does break even mean here? What do you think?
Make the $10,000.
Yeah, we got to make at least the 10,000, but you got to remember it still cost us 2 times the number we made squared for how many we make. So we don't have just fixed 10,000. The cost goes up as we make them because we've got manufacturing cost also that's got to go in there. So many times we refer to, let me come back up here to our profit functions. In business, oh, stop that you. In the business world, there we go. This part right here is called the fixed cost, and this part right here is called the variable cost. It's because it varies based upon how many that you make. So back over here, if I want to find out where I break even, what that means is that profit is 0. That infers to you that P of X is equal to 0. In other words, I made no money, right? I didn't lose any money, but I didn't make any money. I got back just what I put into the company, basically. And it's going to be more than 10,000, notice, because I've been making stuff also, right? So I break even at that point right there, don't I? That's my break even point?
Wouldn't they both be?
Well, they would both be, but I probably, if I'm any sort of an astute businessman at all,
That was where you got to that second point.
I'm going to stop before I get to that second point, right? I'm going, oh man, we are losing money. Stop, don't go here, right? So when they say break even, it's the first time you come through there, right? It's not going to be the second time. This is bankruptcy over here. This is break even over here, okay? This is United Airlines if they don't get their act together, right? And this is you know, making money for the first time. All right, so a couple of different ways that we can do this. We could come in and we can say, okay, 0 is equal to negative 2x squared plus 680x minus 10,000, right? And we can solve the resulting equation there. So remember, this is section 8.3. I don't think we have the quadratic yet, do we? No, I think we're doing all of these in the calculator still, aren't we, right?
Yeah.
Okay, so we're going to need to do that on the calculator. So let's get our calculators out. All right, so second quit. Let's go to the y equals. Can you guys see my calculator okay?
Yeah.
Okay, cool. So negative 2x squared plus 680 x minus 10,000. All right, now we've got some information on how we should be setting our windows so we can see this graph. It's not going to be negative 10 to 10 or negative 10 to 10. If we go back here and take a look at what we answered so far for the vertex, that's really important information because it tells me that I got to go out to probably at least 300 and the center is the axis of symmetry goes through 170. So I'm going to have to go out to, let's see, 200, 340 roughly on the x-axis, maybe a little more. And then in my y-axis, I got to go up to 47,800 and I got to go down to 10,000 because I know that's where the intercept's at, right? So my x-min, can make that 0. My x-max, let's make that 400. I may change that after I go take a look at it. My y-min, that's negative 10,000. My y-max, oh shoot, what did I do wrong? Oh, my bad. Even I make that mistake occasionally. Y-max is going to be, let's go 50,000 so that we can see everything. Y scale, let's make that, oh, I don't know, make it 1,000 just so we don't have a whole ridiculous amount of tick marks there. In fact, and let's make the x scale equal to 10, okay? All right, so let's try that graph for our first guess and let's see how that works. Yeah, it looks pretty good, doesn't it, right? Okay, now what do we need? We need that point right there, don't we? Because that's our break-even point. Okay, so to help us find that, what we're going to do is in Y2, we're going to put a 0 in. Did you guys follow the videos when they did this? Did this make sense using the intersection with the x-axis? And they put y equals 0 as the equation of the x-axis? Yeah? Okay, so now I'm going to go second calc. Go number 5 for intersect. I'm going to make my life easier. I'm going to go down to the horizontal line. Get my little jumping frog over as close to it as I can get it. First curve, second curve, best guess. So it looks like I break even after I sell about basically 16 of them, right? Yeah? Okay, now, I don't know how many of you have got iPhones, but you know on the iPhone, right, you use this app? You guys got that? Are any of you using the iPhone or are you all using the no?
No, calculator.
Using just a calculator? Okay, cool. Because on the iPhone, you get to just touch it. It's so cool. You just get to come up here and you go, touch. And there it is. It's awesome. Anyway, never mind. You guys got calculators. It all works. Okay, so to answer their question, so how many need to sell to break even? They need to sell 16 of them, don't they? Right? Because if they only sell 15, they're still losing money because it's 15.4. is what they got to get. So you got to round that up, even though that doesn't follow our rounding rules. We still got to bump it up so that they break even. All right, so what's the practical, or you can put 15.4 if you want. I mean, that's fine too. You could just say, all right, you know, it's 15.4. And that would work also. All right, determine the practical domain and the practical range of this function. So we actually did that when we set the window on the calculator. So if we come back over here to the window, all right, so the practical domain, well, it's from 0, and it's not quite 400. It's where we actually hit the axis again. And so really we should go ahead and find that second intersection point, because that's going to be very helpful in terms of the practical domain. I mean, you know, if we go to 400, you can see already by looking at the graph, we start losing money again. So, you know, we'd hope these guys are somewhat savvy in business and realize that they need to stop making that many because they're losing money on it. And so these seems like about 324 or so is the upper end. They don't want to make any more than that. So the practical domain here is going to be from, well, from 0 out to 324-ish, right? And then the range, we're talking about the range, well, that's going to go from negative 10,000, because that's how much money we would have lost if we don't sell anything, right? Up to our maximum point, which is 47,800. That's a 4. I know it doesn't look like it, but that's a 4 right there. For some reason, when I'm sharing, it just gets all wonky. I don't know why. My little pen does great on everything but this PDF app. Okay, I think, is that it? I think that's all of them, isn't it? So that takes care of number 8, yes?
Yes.
Okay, all right. So I'm going to come back to number 9, because number 9 actually is really similar to number 8 in a lot of ways. It's somewhat easier because you don't have to generate that profit function on your own. And I'm going to go do 7.3 real quick, okay? So let's go do that. So it was assignment 7, number 17 and 7.5. Okay, so let's go take a look at that. So this is section 7.5, number 17. You guys, do not be shy about jumping in and asking questions while I'm doing these, okay? Believe it or not, this is live and interactive. You can ask questions. It's all good. All right, so number 17. 16, 17. Okay, here we go. All right, show all the work for all the parts of this problem, write your answers in exact form, and then round it to the nearest hundredth. So they want us in both, okay? So an investment is growing at a rate of 8% per year. Determine the doubling time for this investment if the starting value is 10,000, or excuse me, is 1,000, or is 33,000. Okay, so if the rate is 8%, then what's the growth factor?
1.08.
Yes, exactly. Awesome. Okay. So we know 1.08 is our growth factor. So that tells us that our function, right, that we're working with here for part A is going to be the amount in our account is going to be equal to 1,000, right, times 1.08 raised to the t, let's say. I think we were using the variable t here, right? We could have used x also, it doesn't really matter, right? So what do they want to know? They want to know the doubling time, right? So that tells you, what about A? What's A got to be?
2,000.
Yeah, because we're doubling it, right? So 2,000 is equal to, if I go really slow, it seems to not be too upset with me. 1.08t, right? Well, first step in solving an exponential function is I got to get that number off the front out of there, that 1,000. So if I divide both sides of this through by 1,000, hopefully you see that the left-hand side is going to be equal to 2, isn't it? Is that okay?
Yeah.
Is good? All right, cool. Well, so now it's an exponential, but in order to be able to solve it, we need to turn it back into, we need to use a logarithm to get it out of the exponential form. So what that says, it says that the exponent on 1.08 that gets me a 2 is equal to t. And that's the exact form of it right there. So quick reminder about this, okay? If I have got a to the x is equal to y, then you need to know to remember that that's the same thing as saying the exponent on a base a that gets me y is equal to x. Those two are, if you're given this, you can go that way with it. If you're given this, you can go that way with it, all right? So for example, if I had 2 to the t was equal to 17.5, right? Then that would tell me what? Well, it would tell me that logarithm base 2 that gets me 17.5 is equal to t. All right, and that you just got to memorize it. There's no other way of doing it, okay? You got to memorize this relationship right here. It's got to be top of the head. Okay, so let's go back to the problem at hand here because we're almost done. But what we got to do is we got to put this thing in the calculator now. We got the exact form because we just did that, all right? But the next piece is to get that in the calculator. So to do that, we're going to need to use change of base. So to use change of base on this thing, bring it back over here. We'll do it on this side. So to use change base, you've got to remember that if you've got log base b of, let's say, x, change of base says that's the same thing as log base 10 of x divided by log base 10 of b. And the wonderful thing about that is that we've got a log base 10 key in our calculator, right? So what we've got is log base 1.08 of 2 is equal to t, right? Okay, so that means that what? That means that I've got to rewrite this as log of 2 divided by log of 1.08. I got to tell you, when I was memorizing this formula, right, back in the day when we walked uphill both ways to do a math problem, I looked at it this way. See, look at the original one over here. Look, the 2 is up here. The 1.08 is down there, isn't it, right? Oh, look at it here. Oh, the 2 is up here. The 1.08 is down there. You with me? And so it helps me keep straight because I know it's a ratio of logs. I just got to know which one to put in the top and which one to put in the bottom, right? So the one that's subscripted goes in the bottom and the one that's not subscripted goes up in the top. Okay, so let's go get the calculator out. So now what that says is I'm going to come in here, clear all this nonsense out, and we're going to go log of 2 divided by log of 1.08. And it says it takes basically 9 years for this investment to double. Yes, no, maybe?
Yeah.
Okay. All right, so let me set another one up for you, and then I'm going to let you take them for there, okay? Because they're pretty much all the same pattern that happens in here, okay? And that it's always going to be doubled over here on the left-hand side. In other words, this is going to be 6,600 is equal to 3,300 times 1.08 8 to the t, isn't it, right?
Yeah.
Well, every time you divide it out, it's going to be what? It's going to be 2, isn't it? Yes? Look, divide out 3,300 from both sides, and what do you get?
3,300 on that side.
Here, let me move it over here onto this side. If I've got my amount that I'm looking for is equal to 3,300 times 1.08 to the t, right? And I know that this amount right here is double, then that's going to be 6,600, isn't it?
Right.
Okay, so divide both sides by 3,300. And that's going to be back what?
The 3,300.
Mm-hmm. Is this looking familiar?
Yeah.
Is this looking like part A? That's kind of what they want you to see, okay? I'm going to let you take it from there, all right?
Okay.
Okay, cool. All right, let's go back and take a look at that last nasty quadratic one that we were, I think was what, number 9? Sarah, did you want to see number 9 if I recall correctly?
Yeah.
Okay, so let's go look at that one. Excuse me. So an arrow is shot straight up in the air, and the function h of t equal to minus 16t squared plus 90t plus 6 gives the height in feet of the arrow after t seconds. Round your answer to 2 decimal places as needed. All answers must include appropriate units of measure. Okay. So how long does it take for the arrow to reach its maximum height? Write your answer in a complete sentence. Okay, so let's go back over here and let's get ourselves a clean sheet. Okay, so what we know is that we know the height with respect to time, right? Is that right? It's ht, well, they're going to capital H, I'm going to say lowercase, is equal to minus 16t squared plus 90t plus 6. All right, so hopefully, just looking at that for a second, you realize that if this is t and this is h, that our arrow starts at about 6 feet above the ground. Well, why is that? Because we know when t is equal to 0, that's going to drop out, that's going to drop out, and all we're going to have is 6, aren't we, right? So at time 0, before this archer is 6 foot tall is what they're telling you. Before he lets it go, he's 6 foot above the ground, where the arrow is. Then the arrow is going to go up, it's going to turn around, and it's going to come back down, and it's going to hit the ground, isn't it, right? Okay, so the maximum height of the arrow, that's going to be given by this point right here. That's our point again, that's the vertex, isn't it? That's in my lingo, that's HK, all right? Maybe that's a good reason to make this capital H, so we don't get those two confused. So we'll call that capital H. All right, so what do we know H is equal to? H is equal to minus B over 2A. And we know K is equal to H of minus B over 2A. In other words, take whatever function we're working with and evaluate it at H, and it'll give you back what the maximum height was. So it wants to know how long, and then, of course, the next one is going to be what is the maximum height. So A and B, we got to know H, we got to know K, right? So let's go do both those calculations. So let's see. So H is going to be equal to minus B, which is negative 90, right? Divided over 2A, which is 2 times negative 16. Is that making sense?
Yes.
Okay, cool. So what does that equal to?
2.8125.
2.8125?
Yeah.
We'll leave it at that for the moment. And so that's in what units? Because they said you got to put your units on here.
Feet, I assume. Yeah, in feet.
Here, think about it. This is H. Okay. And this is K. So what's the units on this axis?
The time is in seconds.
Yeah, good job. Excelente. Okay. And then the units on this axis, those are in what?
That one's in feet.
Yeah. Cool. So what this is in seconds, isn't it? Yeah. So it reaches its maximum height at 2.8125 feet. Yeah, seconds. Ah, you got me saying it. Sorry. Dag dab. All right, so let's go see if we can figure out what K is, right? So I'm leaving this as many decimal places as we got it because we got to go figure out K and we got to go evaluate our H function of that value. So I want to use as many decimal places of that as I can when I plug it in. So that's going to be minus 16 times 2.8125 squared plus 90, that's 90 there, times 2.8125 plus 6. All right, you guys got your calculators handy. Go ahead and do that one for me, please. Let's see what we get back for K. So that one there, that's part A. We're working on part B right now, okay?
$666.5625.
666.5625.
5625.
Janelle, did you get the same thing? Yeah?
Yeah.
Okay, so what's my units here? I'm in feet, okay? So that's how high the arrow went. All right, now we'll go do what they asked us to because I think they want us to round them off here, right?
Mm-hmm.
So they say 2 decimal places, okay? So we've got 2 decimal places, so we're going to go, what, 8 point...
I did that math on that wrong. It was actually way off.
Was it off?
Yeah, I forgot a parenthesis, so it actually ended up being 132.5625.
I said it's a rocking arrow to go 666 feet. So what was it again? 100 what?
132.5625.
5625, okay.
Yeah, I forgot a parenthesis after the before the plus 6.
Ah. Yeah, you close parentheses are mandatory.
Otherwise, you're roughly
The calculator will not give you good. It really, I got to tell you, it drives me crazy that the calculator doesn't give you an error when you forget to close your parentheses. That's the guys at TI let you down. They shouldn't have let that happen. Anyway, okay, so the length, how long to reach the maximum height? Okay, so that was what? That was 2.8125 seconds. So we're going to round that to 2 places, so 2.81. And I'll let you do the complete sentence, okay? So what does it mean in a complete sentence? Determine the maximum height of the arrow. Okay? So what was the maximum height of the arrow? So that was, going back here, that's the 132.65. And that's in feet. And again, I'll let you say that the arrow flew vibrantly up to 132.65 feet at its maximum height, or whatever you want to write for your complete sentence, okay? All right, how long does it take the arrow to hit the ground? Write your answer in a complete sentence.
So that would just be the intersect thing again, wouldn't it?
It is, exactly. So now we got these next 2 ones we're going to have to, well, we can do the vertical intercept without having to go to the calculator. So I'm going to do D real quick, and then we'll come back and do the horizontal intercept, all right? So the vertical intercept, again, that's going to be at time equals to 0. And so plugging that back into our function here, when time is equal to 0, then we know, we talked about that already when we did our sketch here, that the height is 6, isn't it?
Yeah.
Okay? So when t is equal to 0, then we know that h is equal to 6. And so they want that as an ordered pair. So that's 0 by 6, and then I'll let you interpret the meaning. That basically is what? The arrow, he let it go 6 feet above the ground, or the archer was 6 feet tall. All right, back to this one. How long does it take the arrow to hit the ground? So we're going to have to go get that function into our calculator and graph it so we can see what's going on. So let's go to the y equals. Let's go ahead and clear out y1. We'll leave y2 alone because we're going to need that 0 again. So that was minus 16 x squared plus, what is it, 90x if I remember correctly?
Yes, plus 6.
90x plus 6. Okay, cool. All right, so we've got some idea already what to set our window settings to because we know what HK is and we know what the vertical intercept is, or the y-intercept. So we know we're going to go to 0. Don't know how far to go out, but we know that the maximum height occurred at 2 seconds. So we really don't need to go out much more than, say, 5 or 6 seconds. So we'll just go out 5 seconds, and that should be plenty. And then the arrow should be pretty much close back to being to the ground by then. And if not, if that's wrong, then we'll fix that. We'll come back and adjust our window. And then the Y min, well, that can be 0 because we know we're going to go up, start at 6, and then we know the maximum height was around 140 feet, so we'll put in 140 in there for the max height. And then I'm changing the scales back to 1 each, or actually we'll go 10 on the Y scale. Okay, so let's see if that worked on our graph. Pretty close, but it looks like I got to go a little longer. I didn't quite go out long enough on my x-axis. So let's go ahead and go, I don't know, it's got 8 seconds, and then we know we're going to get it. And then actually, you know what I'm going to do? I'm going to Y min. I'm going to give us a little room down there. I'm going to go negative 20 because we're going to need to see where it actually passes through. There we go. Okay, so that's a pretty good window to help us find what we need to find, because we need this point right here. We need to know how long until it hit the ground, right? So we're going to go second, calc, number 5 for intersect. And then we'll scroll on down to the intersection point we're looking for here. And we'll say first curve, second curve, best guess. And it looks like about 5.69 seconds we hit the ground, right? So how long does it till it hits the ground? So, oops, pen over here. 5.69 seconds, it looks like. And again, I'll let you put in the sentence, okay? So you guys get to write this complete sentence. Okay, what is the practical domain and practical range? And so what do you think we ought to have for the practical domain here? Well, we know that we're talking about time here. So if you want to use inequality notation, one way you could do it is say, well, t, it's got to be greater than or equal to 0 because we have a starting time. But if we go back to our graph here, well, look, we're not, the arrow is not burrowing into the ground, right? So after 5.69 seconds, we're done. The arrow is not flying anymore. The arrow's in the ground, right? So that says it's less than or equal to 5.69. So that's our practical domain. Now you could, of course, again do this in interval notation. You can go from 0 to 5.69 in brackets because I'm including my endpoints. All right, what about the practical range of h of t? Well, notice it doesn't start at 6 for our range because we go all the way down to 0, don't we? Because you can be on the ground. When the h is equal to 0, we're on the ground. So that says that 0 is less than or equal to my h, or my h of t, if you'd like to put that in there. And then what was our height again? What was our maximum height that we got up to?
132.56.
It was 5.6? I put 6.5. Was it 5.6?
5.6.
Okay, sorry about that. So 132.56. Okay, so what that tells me is that my HT is going to be less than or equal to 132.56 also. Is that making sense?
Yeah.
I am totally understanding it now.
Perfect. Perfect. So you can go back and correct those and life will be good, right? Okay, so can I let you do G and H on your own?
Absolutely.
And all the rest of these are just graph and calculator ones, right?
Yeah. Basically copy that graph that we have on there.
Exactly. And then on part I right here, I'll show you what to do on that one. On part I, you don't leave it 0 anymore. Come back to your y equals. Change your y2 to 80.
Oh. That was another one I was having issues with. I didn't.
So watch what happens when I change the y2 equal to 80. So can you see where it's going to be at 80 feet now?
Yeah.
It's going to be there and there. You got 2 spots. So you're going to come in and go, okay, second, calc, number 5 for intersect. And you're going to have to do it twice because you got to do it for each one of the intersection points because there's 2 times in the flight that it hits 80 feet. First curve, second curve, best guess. So at 1 second is the first time it hits 80 feet. And then it turns around and comes back down, right? And so there's another time it's going to hit 80 feet. Let's see where that's going to be at. By the way, if you hit the up arrow, it'll go to the line, and it's a lot faster scrolling over there, okay? You can toggle between the graphs by hitting the up arrow. It'll go back and forth between them. Okay, so then first curve, second curve, best guess. And at about 4.625 seconds is the next time that we're going to come through 80 feet. What do you think, Sarah? Is that okay?
Yeah.
Cool. All right. We are just at 9 o'clock. So I could give you like another couple minutes if there's something that I got to answer.
I think I'm getting it now.
You get it? Janelle, how you feeling? You good?
Good. Yeah, I got that one. Yeah.
Okay, great. All right. So do not be shy, you guys, about asking for additional office hours if you get stuck. I know your guys' office hours early in the week. It's okay to say, hey, it's Sunday night and I am stuck, or Monday night and I'm stuck. Can we have one here? And if I can fit it in, I'll definitely do that, okay?
All right.
Yeah, thanks.
You are welcome. All right. Well, hopefully that was all good.
Yeah.
And life is good. And we'll be done for the night. And I wish you all a good evening. And I'll see you next time we get together, okay?
Have a good night.
Perfect.
Good night.
Bye.